All right, this is a lecture 10.2, Graphing Linear Equations. What we just learned in 10.1 was how to plot points, because we need to know how to plot points, how to figure them out, solve for missing variables, because without points, we can't make a graph. So a collection of points always makes some kind of graph. We have all different kinds of graphs, as I showed you all in the last lesson. There's something called an exponential. You'll learn about ones called parabolic or parabolas. You'll see logarithmic, all different kinds of graphs you'll see in the future. For right now, what we're working with is something called a linear graph, so linear equations. If we look here for the word linear, it actually has the word line in it. So linear equations are lines. They create straight line graphs. So if you look at all these points that are right here for our graph, we have 1, 2, 3, 4, 5 points. If you connect all of the dots, we notice that they actually make a straight line. So straight lines are linear graphs. It looks like a straight line, hence linear. Now, in order to make a linear line, they have to have certain properties. Certain equations can make linear lines. So let's go ahead and look at the next page. It'll show us a little bit about what a linear line is. All linear equations are in two variables, or at least two variables, 1, 2, x and y. The a and the b and the c just mean they can be any kind of number. Like the a can be 2, the b can be 3, the c can be -4. It doesn't matter what it is. The whole idea, though, is if x and y are present, then that would make a linear line. Now, it depends on the type of x and y that are present, but only one of each. So we have 1x, 1y. Later on, you'll learn something maybe in calculus. If you go over to calculus, some like 3 dimensions, you can have something called a z variable, and then that would make a 3-dimensional object, but it makes a straight line. For right now, we got x and y, and that's going to make us a straight line. And here's some examples right here. Here it says standard form for the equation, and you have x and y and 8. This right here, this ax plus by equals c, that's standard form. The equation is already in standard form. But if we look at this other one, like right here, the second one, it has x and y, but it looks a little different in terms of like numbers being on one side and the other side. It doesn't matter where they're at. As long as there's one x and one y, then it's a linear equation. If we look at the third one, so like this one right here, we have a y right there, and we have an x. As long as we have an x and or a y, and only one of them, that would make a linear equation. If we look at the fourth one, that has just a y on it. So the thing is, it has to have either an x or a y. The x isn't present because, say, if we look at this equation up here and a was 0, if a is 0, 0 times x makes 0. So the x is still kind of present. It's just that its coefficient is gone. So that makes the x disappear. So we're left with y equals 7. And we'll see, like in the next few lessons, what types of graphs we get depending on what all the numbers are. So if we look over here, we have different types of equations. I'm going to look at these practice problems because they show different ideas and different graphs. So if we look at practice 1, example 1, it also wants us to see which ones are linear lines. So if we look at A, we have an x and a y. As long as there's an x and a y, it's considered a linear equation. So A is considered linear. B is also linear because it's got a y and an x. Nothing else. C is an example of a non-linear equation because notice it has an x and has a y squared. Remember, y to the second power, y squared means y times y, right? So that's technically 2 y's. Because of this squared up in the top, it is not a linear equation. This is something called a quadratic equation. You'll learn about quadratics, especially this one where the y is squared. Probably more so in college algebra and your pre-calc class. The last one, D, this one would be a linear equation because like the one up here where it says y equals 7, x equals 5 is also going to be a linear equation. Just different variable, it's x, but it's still a linear equation. Going to these examples over here, x and y, linear equation. X squared and y, this one is not linear. So B would not be linear because it's got x squared. C would be linear. D would also be linear. So just like a couple examples of ones that are not linear, we can see that anything that has a squared would not be linear. If we had something like x squared plus x equals y, you'll probably see these in college algebra. That one's not linear as well. These are all going to be not linear. Another one that you're going to see later on in college algebra is like an equation like y equals square root of x. That one, even though it has one x and one y, it's actually a square root. This thing right here is called a square root. So it doesn't have one x variable by itself. It would not be a linear line. Another example would be if I had y equals 1 over x. Even though that this one has, right here, this one has an x on the bottom, it doesn't matter because it has a whole fraction around. This is one giant fraction, so it would not be a linear equation. And then finally, you might even see this in college algebra. Y equals, you might see log of x. The word log, that's a different thing called a logarithmic function. You're going to learn all about that in college algebra, but that's another one that's not linear. So all of these right here, all of these graphs right here are considered not linear. You just have to look at it. You just have to look at the equation and see that it only has one x and one y and nothing else around it. No fractions, no exponents, and no logarithmic functions either. Now, don't get confused because if we look at something like this one right here, that has a 1/3 x. But notice the x itself is not in the denominator. Like that other example I gave, I said 1 divided by x. That's different than 1/3 x. 1/3 x means 1/3 of x. If it said 1 over 3x, that's different. That would be something called a rational equation. So if I did an example like that, these are going to be totally different. Y equals 1/3 x plus 2. That's considered linear. What is not linear is something like y equals 1 over 3x plus 2. Notice the x is in the bottom right there. That would be considered not linear. So erase that. With the x in the bottom, it's considered not linear. So this one is linear. This one is not linear. Just a key little difference. Now, whenever we graph equations, we can tell if they're linear or not once we actually graph them out. So let's go ahead and start graphing some of these linear equations using examples from the book. If we look at, let's go to the next one. Let's go to the next page really quick. It's got to load up. So we're going to graph this equation right here. This one is considered a linear equation, 2x plus y equals 5. So from here on out, I'm going to kind of graph some of these by hand. I'm not going to really use the book. I'm going to go back over to, what it would look like on a piece of notebook paper and how we would do it. So let's go over here, and I'm going to show you all how to graph it. This was example 2, and it wants us to graph y, 2x plus y equals 5. Now, to graph any linear equation, we're going to do what we did last time. Remember when we substituted one value, like here in this example, we can see We have x and y. We're substituting a value for x and solving for its remainder value. That's what we're going to do in order to find a graph. Now, in order to graph any linear equation, we only need 2 points. Because if you think about it, let's say I draw like a random dot. If I draw a dot, this is kind of the basic rules of geometry. If I draw a dot and then I draw another dot, I could connect those two and that would make a line. So really I only need 2 dots or 2 points to make a line. Again, if you actually put another dot in here, rules of geometry, 2 dots make a line, 3 dots make a shape or two-dimensional figure, 4 dots would make a 3D shape. So this would be like a pyramid. And then I could clean it up a little bit, make it look a little more real. But anyway, that's a interesting looking graph. We're here to learn about straight lines. So this is what we're going to do. One of the easiest ways to solve and to make a graph is to make a T-chart. So here's that T-chart. Again, we're going to do X and Y, and we're going to create a T-chart. You are welcome to pick any value you want for X and any value for Y whenever you're doing these problems. So I can choose any X value and start solving for Y each time. Me personally, I like to keep it to like smaller numbers. Like I might use like, let's say like -2, 0, and 2. So I'm choosing any kind of number that I want. It doesn't matter what you pick because whatever number you pick for your equation is going to graph the equation correctly. So we're going to go ahead and solve each one. I'm going to say for x equals -2, 2x plus y equals 5. Substitute the -2 in for x. And all you got to do is start solving for y. Here's your chapter 9 stuff coming into play. 2 times -2 is -4 plus y equals 5. Solve for y, you got to add 4 on both sides. These cancel out. You're left with y equals 9. So when we plugged in -2, we got y equals 9. So we're going to put 9. Plugged in -2, we get 9. Let's do the same thing for the next one. X equals 0. I always pick 0 because 0 is usually a really nice number to substitute because if we look here, 2 times 0 plus y equals 5. Anything times 0 just becomes 0. 0 plus y equals 5. And 0 plus y just makes y equals 5. There you got it. So when we plugged in 0, we got 5. Technically, you only need 2 points to make a line, but let's go ahead and work out the other one. X equals 2. So 2x plus y equals 5. 2, substitute a 2 in. 2 times 2 makes 4, plus y equals 5. You're going to have to subtract 4 on both sides. And you end up getting y equals 1. And there you have it. So y equals 1. Let's go ahead and put that on our T-chart. There we go. So what happens is that makes 3 different points that we have. We have -2, 9. We have 0, 5. And we have 2, 1. Those are the 3 points that we're going to graph. Now again, when we're sketching graphs, you try to make them as straight as possible. If all you have is notebook paper, you're going to go ahead and try your best to make a straight line. I have a little straight line tool, so kind of cheat, but even then, I might have some issues making it completely straight. Then it's on a tablet, so I don't have a shift button to press to force it to be straight. I draw this line right here. I might just shift that down just a tad. Oh, it's not letting me select it. There we go. And shift it down. There we go. And remember, you want to go ahead and label it. Now, when we label our graph, I like to keep it, again, proportional. And I like to look at all of my points here. If I look over there, I see x doesn't go any further than -2 and 2. So I don't have to make it that large. I can make it, a 5 by 5. Here, looking at these points, the largest number is 9. So largest number out of all of these right here is going to be 9. So I'm going to make my t-chart to be a 10 by 10. So I'm going to put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Y'all pay me. You'll pay the school. Pay me to watch me draw tick marks. Isn't this fun? There we go. So got 10 marks on each side. Go ahead and label your points. I'm going to use, I don't know, I like purple. Purple's a cool color. Let's do -2, -9. -2, -9 would be -2, 1, 2, and then up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And there we go. There's -2, -9. That was this point right here. I can just do a different color so we can demonstrate where the points go. 0, 5, that would be 0, left and right. We don't move left and right. We go up 5. 1, 2, 3, 4, 5. Right there. And then our other point, I'll do it in green. That would be 2, 1. That'd be 1, 2 to the right, up 1. There's our 3 different points. Once you have the 3 different points, you want to go ahead and connect them all together. I'll just use the black. Now, here's the problem with sketching your graphs on a piece of paper. You can see I have this straight line tool. I want to try to connect them to the best of my ability, but you see how they're kind of off? It doesn't connect all 3 of them perfectly. That's because we're not actually using graphing paper, which I'm going to show you in the next example. But when you sketch it, it doesn't have to be perfect. It just should have that general look to it. Draw little arrows on the ends. That's your graph. Again, really, you only need 2 points to make the line, but you can have 3 points or more. Now, what makes it harder, though, is the fact that we don't have graphing paper, what we're using. So what I'm going to do is, for this next example, I'm going to change my page settings. We're going to change it to graphing paper. There we go. Fantastic. I don't know if I want it to be, oops, wrong one, page settings. I'm going to change it to not 5 square inches. Thought I had a smaller one. Let's do 4 square inches. This way the squares are a little bigger. Okay, so let's do example 3. Once they do the same thing, graph. And this time the equation is -5x plus 3y equals 15. Okay, so this one, equation looks a little different, but it's going to be the same process. We first need to make a t-chart. Now, I told you that you only need 2 points to make a line. Now, my math lab might force you to do 3 points to make a straight line. Any straight line, you really only need 2 points. So if it's like a written test, personally, I wouldn't care if it was 2 points, but my math lab might require 3 points. When you graph other things in college algebra, parabolas, logarithmic functions, you will need more than 2 points because there's curves. You need to kind of get the general shape of the curve. But for a straight line, you just need 2 points. So here's how we're going to make it easier. We're choosing our points. I'm looking at these values right here. I have 5x, or -5x, and 3y. The easiest number to choose is always going to be 0. So for one of the points, I'm going to make x equal to 0. Now for another point, we have the freedom to choose an x or a y point and solve for the unknown variable. So for y, I'm also going to use 0. Notice these are 2 separate points. They're not the same thing. So we have one with x equals 0, and we have one with y equaling 0 that we're going to solve for. So let's go ahead and evaluate those 2. If we make x equals 0, -5x plus 3y equals 15. Substitute the 0 in for the x. -5 times 0 is 0, so we don't even need that. That'd be 3y equals 15. Solve for y, you got to divide by 3 on both sides. So that would give us y equals 5. Put that point in. For this, we got 5. And our other point, this time we're saying y equals 0. So negative 5x plus 3y equals 15. We're going to make y equals 0. It's not x this time. We're making y 0. But notice 3 times 0 makes 0, so we're left with negative 5x equals 15. Solve for x, you got to divide by negative 5 on both sides. And that gives us x equals negative 3. And there you have it. Negative 3 we'll put in for there. So notice we put negative 3 on the x because that's what we found, but we substituted 0 for y. Again, my math lab might require you to find another point, so we could use another easy point. I might use 1 for x. I'm going to use 1 for x. We want to evaluate that. X equals 1. And we're substituting negative 5x plus 3y equals 15. This would be negative 5 times 1 plus 3y equals 15. And notice it doesn't just become 0 anymore because we substituted 1. So it makes it a little bit more difficult to solve the problem. Negative 5 plus 3y equals 15. Going back to your algebra, so we got to solve for y. That's our goal, is to get that by itself. Got to add 5 first. 3y equals 20. All right, and then divide by 3 on both sides. So you get like an ugly number. Y equals 20 over 3. 20 over 3 is an exact answer. So what you want to do is, in order to graph 20 divided by 3, it's easier to just approximate it to a decimal, just so we can graph it. So 20 divided by 3 is something like 6.67. I'm going to approximate it just so we know where we need to put it on the graph. 6.67. I didn't put it in the blue. There we go. 6.67. Let's go ahead and start graphing. So notice whenever you use graphing paper, though, all the lines are straight and everything. Everything's already done for us. Erase all this. I'm going to go ahead and pull this line tool. And I'm just going to follow the line. Maybe I'll just make it this large. There we go. And I like to kind of maybe split it in the middle. I'll put it like right here. There we go. Might not be perfectly proportional, but it looks good. And we're going to count the little tick marks. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. You can see how I obviously didn't make it proportional on all sides, but it doesn't have to be, just as long as the graph looks neat and nice. I also included enough tick marks to include all the points here. There's no number larger than 7, and I have more than 7 on all sides of the graph. So let's go ahead and do it. I'm going to put them all in blue dots. 0, 5 is going to be 1, 2, 3, 4, 5 right here. That's 0, 5. Negative 3, 0. 1, 2, 3 is going to be right there. That was kind of bad placement. And then 1 and 6.67. This will be 1 to the right, and then it'll be up 6.67. So it's 1, 2, 3, 4, 5, 6. 6.67 is like 2/3 of the way, so it should be like kind of right here. And that'd be perfect. But you notice when we connect all of the dots, I'll do like purple. I'm going to get my line tool, and we're going to go ahead and connect all of the dots. So we can see it goes through all of them a lot neater than it would if I didn't put it on graphing paper. There we go. Now, whenever you draw these lines, you always want to use like a ruler So line up all the points on your ruler, right? You want to line them all up on the ruler. There's your edge of the ruler. You're going to trace the black one is like your ruler. The purple would be where you want to trace the line. So whenever you make these graphs by hand, always use a straight edge. It could be a ruler, it could be like the side of your ID card, anything that has literally a straight edge, right? You don't want to use something that's round, then it won't work. Maybe the edge of your calculator. If you have a calculator and you have that little cover that goes to it, usually the cover has a straight edge. You can even use that. Just anything to trace the line and make it perfectly straight. All right, so that's graphing so far using the T-chart. Let's see what the book has another one. We got another interesting looking one. Let's go ahead and do example 4. This one wants us to graph y equals 3x. Again, easiest way to graph something is to just make a T-chart. I'm going to make x equal 0. That's one of our easiest ones. Now, for this equation right here, I notice strategically the easiest way to graph this equation is to always substitute values for x. I mean, I pick 0, I'm going to pick maybe -2 and +2. The reason being is because whenever we substitute something for x all the time, we end up getting y automatically. So no matter what value I put in for x right here, it already spits out a y value because y is solved for. It's already solved for by itself. So when I evaluate y equals 3x, y equals 3 times 0, so that means y is equal to 0 for that one. If we plug in x equals -2, y equals 3x, y equals 3 times -2, that gives us y equals -6. So solving for y makes it a lot easier. X equals 2, y equals 3x, y equals 3 times 2, so y is equal to 6. There's all of our points. So go ahead and make a linear graph. Let's make this graph. Again, you just kind of estimate it. It doesn't have to be perfect, but with graphing paper, it's a lot easier. And then go ahead and mark it up. I'm going to assume each one is 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. No matter as long as it fits all of these points. So 0, 0 would be right in the middle. -2, -6, 1, 2, 3, 4, 5, 6. And then 2, 6, 1, 2, 3, 4, 5, 6. All these right here connect and make a straight line. There we go. And then I'm just going to use my little tool because I don't really have a ruler to trace it out. Just going to extend this out and then put the little arrows on the end. And there you got it. That would be your entire graph. And again, you only needed 2 points, but we're doing 3 points just to make sure to have it down. So let's try another example. Learn by example, keep doing a bunch of different ones. Let's check out fractions. Example 5. Graph y equals -1/3x plus 2. This one a little trickier. First off, notice it's solved for y already, so I just want to pick x values for my t-chart. Easiest way to get around fractions so that you don't get fractions as answers is whatever number we choose for x, we want it to go into this denominator. And we learned that when we were talking about LCD. So for your x, for one of the easiest numbers to choose is 0. 0 is always a nice number. Let's choose values that 3 can divide into whatever we choose. So we want to choose multiples of 3 so that we don't end up with a fraction. So for x, we can choose maybe 3, 6, 9, 12, 15, 18, 21, 24, or -3, -6, -9, -12, -15, a bunch of different numbers that are multiples of 3. So let me demonstrate just by picking, like, let's say a -6. 6 is a multiple of 3, so it will simplify and go into 3. And then I could pick like a positive 12. That will divide into 3 nicely as well. Let's demonstrate. So let x equal 0 for the first one. Y equals -1/3 x plus 2. Y equals -1/3 times 0 plus 2. Anything times 0 makes 0, so we're just left with 2. 0, comma 2. Let's do -6. Y equals -1/3 x plus 2. Substitute the -6 in for the x. So now we can see 3 goes into 6 twice. That's where we simplify using the LCD. Then remember, a negative times a negative makes a positive. So 1 times 2 makes 2. Bring down the plus 2. Y is equal to 4. We get 4 when we plugged in -6. Let's do the next one with the fraction. X equals 12. That's a big number, but because we have a fraction, it's actually going to cut it down a lot. Substitute 12 in for x. As you can see, since 12 is a multiple of 3, 3 goes into 12 4 times. And a negative times a positive makes a negative. So it'd be -1 times 4 makes -4. Plus 2, we end up getting -2. That's always a nice shortcut with fractions. Try to choose a number that the denominator can go into. This way it divides nicely. Go ahead and graph it. And let's see, draw this right here. Gonna draw another line right here. And gonna erase my little hand marks. All right, so 0, 2, I'll use blue. We're gonna assume all these little intersections right here are gonna be 1. I'm not gonna draw the little tick marks because I have the graphing paper to do it for me. 0, 2 is right here. -6, 1, 2, 3, 4, 5, 6, and then up 4, 1, 2, 3, 4. It'll be right here. And then 12, -2. There we go, so that's 12 is way over here, but that was where the x is. It would actually be like right around here. But again, it doesn't matter. It doesn't have to be 3 points. We can just connect the 2 points. You'll see that it will run into the other point anyway. So draw a line all the way over here, and it'll intersect about there. That's good enough. As long as we get the gist of connecting the points. Then go ahead and put your little arrows on the end of it. So whenever we're doing an equation with a fraction, it's always easier to just choose numbers that go into the fraction. It makes it a lot easier to deal with. Lastly, let's look at these other interesting types of graphs. Let's look at example 6. It wants us to graph y equals -2. So remember, we said y equals -2 is considered a linear graph. Well, in order to graph something that only has a y coordinate, basically it's saying, hey, y always has to equal -2. It can't equal anything else. It's saying y equals -2. There's no x that's going to actually change the y value. So what happens is, essentially, all of these are always going to be -2 because it's just y equals -2. If there was an x right there, I can't assume that. That would not be true for y, because it'd be y is equal to -2x. Depending on what I put in for x, it's going to change the y value. But since there is no x, it's just going to be -2. So that means for every value of x I choose, no matter what it is, it's always going to be -2 for the y value. So if I was to graph this really quick, I'll make a little tiny graph here. Put this up one. You can see, let's make every one of these like one coordinate point. You can see if I graph -1, -2, that's right here, 0, -2, and 1, -2, all these dots connected end up making a straight horizontal line. Interesting, right? So if it says y equals any kind of number, it's always going to result in a vertical or a horizontal line. But if I have, let me make up just another example. This is going to be like my own example. Let's say we graph x equals 3. Well, there's no y for it to say anything. Like x is always going to be 3 is what it's saying. It doesn't say x equals 3y. It just says x equals 3. So for every y value, again, I can do -1, 0, 1. It doesn't matter what y value I choose. It's always going to be x equals 3. So when we graph it, if I graph this equation, oops, that was terrible. Do it right here. Good enough. It doesn't have to be perfectly proportional. As long as it fits everything. 1, 2, 3, 4. 1, 2, 3, 4. 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Almost height proportional. 3, -1 is right here. 3, 0 is right here. And 3, 1 is right here. So if we notice, all of these connect and make a vertical line. So the rule for all of this is if your equation says x equals some kind of number, c is going to be some kind of number, you're going to end up having a vertical line. But if you have y equals some kind of number, that's going to end up being a horizontal line. Kind of a trick. Anytime it's just some number, y equals a number or x equals a number, you can just take the shortcut. So if I look at this one said y equals -2, I can refer to, hey, if it's y equals a number, it's going to be a horizontal line on that number. So y equals -2, I should draw a horizontal line at -2. That would be the shortcut. Same thing for like x equals. If it's x equals a number, I know x equals a number should result in a vertical line. So I'm going to go to x equals 3, which is right here, and draw a vertical line right there. You don't even have to draw all the points. You can just immediately draw the type of line for your equation. That will give you the answer. All right, so that pretty much wraps up graphing equations. You can check out example 7 by yourself if you'd like to. I don't really go that much into it. Talks about shifting graphs and how they change, but you cover a lot of that in college algebra, and I don't want to kind of mix it in with this just yet. But it's 10.2. Go ahead and go over to 10.3. We'll talk about more things with graphs later on for the rest of the section. We're going to talk about slope and different methods of graphing equations. So right now we just used one method, which is choose any point you want, and that's how you graph an equation. And then you make a t-chart, connect all the dots, and that gives you your answer. All right, well then go ahead and check out section 10.3.